All right, section 7.6 video. I want to continue solving radical equations. We did 3 examples in the last video, A, B, and C. And I have 2 more examples that I want to do with you on wrapping up solving radical equations. So the instructions on the last video was solve the following. We had done A, B, and C. So this is example D right here. So copy this. Pause the video and copy this down. All right, you may not recognize this, but if you watched the last video right before this one, 7.6 part 1 video, this is one of the first ones I put up. Now, we didn't solve it, but if you took notes off of that video, if you'll flip back, you'll see where we wrote this problem. And I told you that the answer was 5, and I showed you that the answer was 5. But I told you I haven't shown you how to get to that answer. Well, since then, I have given you the 4 steps to solving this equation. So if I use the 4 steps to solving this equation, I should come up with that answer. All right, so let's see if we can get to that answer by using the 4 steps from the last video. I will remind you of what those 4 steps say. This problem has a little bit different twist to it. I'll talk about that as we go along. Step 1. Isolate the radical term by itself. Well, the radical term is not by itself. So what I want to do is get this radical by itself. To do that, you have to get rid of the adding 2. When I do, I subtract 2 from both sides. The 2's add out. Now, here's one thing that makes it different. In the previous 3 examples, this was a number over here, like 7. Well, what's 7 minus 2? It's 5. But this time there's an x over here. Well, x minus 2 is just x minus 2. You can't subtract those. So I've just got to write it down like that, x minus 2. That's the first difference, is it's not a number over here anymore. It's x minus 2. It's a binomial. All right? That's going to change things as well. Step 2, square both sides. Now, when you square the left side, we've already talked about this. That's easy. When you square the square root, it gets rid of it. But remember, let me back up just a second. You must isolate first before you square. It's isolate and we square sides. So if you pop in here and just square each individual term, that whole problem is wrong. It's isolate and then square. All right, when you square this square root, it gets rid of it. Now, this is the part where if you're not careful, you'll make a mistake. First of all, if you're not careful right here, you'll write x squared plus 4 or x squared minus 4. Both of which of those are wrong. Remember, when you square a binomial, you get a trinomial. Let me come over here to the side. So remember, when you square this, you don't just square the first one, square the last one. You have to do this. This is my scratch work over here. So when I FOIL this would be x squared minus 2x minus another 2x plus 4. Which is x squared minus 4x plus 4. So when you square this binomial, you have to use the FOIL method. So this is what you get for the right side. So there's 2 differences so far. The first difference was this was an x. The second difference, because it's an x, when you square it, you have to do the FOIL method. Now, here's the third difference. In the first 3 examples that we worked, when we got to right here, we had a linear equation that was left. If you will notice in this equation now, you have a x squared equation, a second degree polynomial equation. We give that a special name. This is not a linear equation now. This is called a quadratic equation. Now, where did we solve quadratic equations? Section 5.8 videos. We worked and we looked at solving I worked about 10 or 12 examples in 5.8 on solving quadratic equations. I will remind you of the steps. Step 1, when you solve a quadratic equation, it has to be set equal to 0. So we have to bring everything to one side. Now, here's my equal sign. When I bring everything to one side, I can do it one of two ways. I can get all of the terms on the left side, and get 0 over here, or I can get all of the terms on the right side and get 0 over here. Now, typically what I prefer to do is to get the 0 on the right side. So typically I would move these 3 over here. Here's the problem with that. If you'll notice, this x squared is the only x squared in the problem. When you bring this x squared over to this side, it's going to be negative. And I don't like factoring an x squared problem where the x squared is negative. So here's what I'm going to do. When I bring all the terms to one side and set it to 0, I'm going to bring these two terms to this side. So I'm going to get my 0 over here. All right, so when I do, here's what it would look like. 0 equal x squared minus 4x plus 4. And then you minus 19 across and plus 2x across. So now, I know that some of you say move it across and switch the sign. You're really not moving it across, but again, whatever works for you. But you're really subtracting 19 from both sides and adding 2x to both sides. Now, when I do that, I can combine some terms. Negative 4x plus 2x is minus 2x. And then 4 minus 19 is minus 15. Now, why did I put it in that order? You have to go back to 5.8. Remember, in 5.8, when you solve a quadratic equation, it has to be set to 0. It is. And it has to be in the right order. It is. Put your x squared first, then your x, then your constant. Now, you don't have to you can factor it from here, but if this bothers you and you want to write it this way now, you don't have to. But if it bothers you and you want to write it that way, it's the same thing. But you don't have to. All right, so how do we solve a quadratic equation? It's got to be set to 0. It is. It's got to be in the right order. It is. Now factor it. A trinomial, there's no GCF. This is the easy case. X squared breaks up x times x. Signs are different. Largest is negative. So the largest number is going to go right there. I need two numbers that multiply to give me 15, but subtract to give me negative 2. That's a negative 5 and the positive 3. So the 5 has to be behind the negative. Now take and set both of these equal to 0. When I do, I subtract 3 from both sides. To get x equal negative 3, add 5 to both sides to get x equal 5. Now, if you will notice, I did not circle these. And the reason I did not is because there's a step 4 in radical equations. What step 4 say? You have to check your answer. So this is another thing that makes this one different. Because it was a quadratic equation now, I don't just have one answer to check. I have how many? 2 answers. Now, before I check these, let me say this. When I check these, it is possible that both work. If they do, I'll circle both. It is possible that neither one of them work. If neither one of them work, I'm going to mark both of them out and say what? No solution. But the only way it'll be no solution is if both of them fail to work. But then there's another possibility. It's possible that the negative 3 will work and the 5 won't. In that case, I'll have one answer. Or it's possible that the 5 will work and the negative 3 won't. I say all of that to say this. I have no way of knowing which one of these, or if either one, or if neither, or if both work, until I check both of these individually. So let's check. I must show my check work. All right, when I show my check work, you write the original problem back down before you touched it. Now, I'm going to go ahead and do it twice. And the reason is, how many answers do I have to check? I have 2 to check. All right, so let's check this one first, -3. That means every place you have an x, put a -3. So this is 19 minus 2 times -3 plus 2 equal, and you got to put another -3 there. Don't move anything, don't square anything. Do the math. So this would be square root of 19. -2 times -3 is going to change that to a +6. Bring down the +2, and then the equal -3. This is 19 plus 6 is 25, plus 2 equal -3. Square root of 25 is 5, plus 2 equal -3. So this is 7 equal -3. No. So, it turns out that doesn't work. Now, what would I do if it had worked? I'd have circled it. But I still have the other one to check. Now, you said, well, a while ago when they didn't work, we said no solution. That was because we only had one potential answer. In this one, we have 2. So, let's check this one now. Well, the other answer is, the potential answer is 5. So, this is 19 minus 2 times 5. Plus 2 equal 5. This is square root of 19 minus 10 plus 2 equal 5. This is the square root of 9 plus 2 equal 5. Square root of 9 is 3 plus 2 equal 5. And that is certainly true. 3 plus 2 is 5. So that means then that that answer does work. So if that had not worked, like if this had been 3 plus 1 equal 5, I'd say false, and then I'd mark it out and say no solution. So it's possible for one to work, both to work, or neither one of those to work. So the answer to this problem is 5, which is what the answer I told you in that last video at the very beginning, that I told you that was the answer to that problem anyway. So that's how you get to that answer. All right, let's do one more. In this video, now you've got one like this in your homework, so make sure that you copy this one down. And there's actually 2 ways you can do this one. So if you view an example, he may show you a little bit different way than I do it. All right, step 1. Get the radical term by itself. Now here's the thing that kind of jumps out at me about this problem is this, that my radical term has a negative in front of it. So here's what I'm going to do. Now there's 2 ways to do it, but I'm going to show you this way. Since my radical term has a negative in front of it, I'm not going to move this x over to the other side. Here's what I'm going to do. I'm going to move my radical term over to the other side. And when I do, what will that negative in front of that radical term then become? When you move it over to the other side, it becomes what? Positive. But you got to get the radical by itself. So I can't leave this over here. So I've got to bring this term back over to this side as well. So I'm really doing 2 moves. I'm adding the radical term, but I'm adding the 7. So when I do this in one step, the x is going to stay there. I'm going to add the 7 to both sides. And then when I move that radical term over to the other side, it becomes that. Now notice 2 things when that radical term goes to the other side. First of all, what's under the radical never changes. Never. But notice now what's in front of the radical term is now a positive coefficient instead of a negative. All right, so that's step one. Step two, square both sides. Now, when you square the right side, that's easy. It just gets rid of the radical. Now, how do we square the left side? Squaring a binomial. We do it just like we did in the last problem. Let me write it over here. X plus 7 means x plus 7 times x plus 7. FOIL method. So this would be x squared plus 7x plus another 7x plus 49. Or x squared plus 14x plus 49. Or you could use the shortcut that I showed you when we were squaring binomials to get this. When you square a bi, you get a what? Trinomial. So this would be x squared plus 14x plus 49. Step 3. Solve the equation that's left. Now, what kind of equation is this? It's a second degree polynomial equation. We have a special name for that. What's it called? Quadratic equation. How do we solve a quadratic equation? That comes from section 5.8. Step 1, it has to be set to 0. All right, so I can either bring everything to the left or take everything to the right. I want that x squared to stay positive because I got to factor it. So what I'm going to do is leave that on the left side, and I'm going to bring everything to the left side. When I do, it would be x squared plus 14x plus 49, and then there would be minus 5 on both sides and plus x on both sides. So to get rid of the 5, you subtract 5 from both sides. That got rid of that. To get rid of the minus x, you add x to both sides. So there they are. Now everything is on the left side and it's equal 0. But I can clean this up. This would be x squared. 14x plus 1x is 15x. And then 49 minus 5 would be plus 44. Equals 0. All right, now factor it. It's a trinomial. There's no GCF. This is the easy case. If there was a 3 or something like that here, I'd have to use the brew method or the bottoms up method, but brew is what we call it. So, you could run into all of those various techniques of factoring right here when we solve quadratic equations in 5.8. But this is a trinomial, the easy case. X squared breaks up x times x, signs are the same, both plus. Two numbers, when you multiply, you get 44, but when you add, you get 15, and that's 11 and 4. 11 times 4 is 44. If you add 11 and 4, you get 15. Now take and set each one of these equal to 0. And when I do, I get the 2 potential answers because this became a quadratic equation. It didn't start out a quadratic equation, but it turned into one after I squared both sides. So what I'll have to do in step 4. Step 4, I've got to check my answer. And since I have 2 answers to check, I'm going to write the original problem back down twice. Now let me say once again before I check both of these. It is very possible that one work, both work, neither work. So I have no way of knowing until I check. So every place check negative 11. Every place I have an edge, put a negative 11. So this would be negative 11 minus the square root of 5 minus negative 11. Equals negative 7. This would be negative 11 minus square root of 5 minus negative, double negative gives you 5 plus 11, which is 16. And then negative 11 minus square root of, bring the minus down, square root of 16 is 4, equal negative 7. And negative 11 minus 4 is actually negative 15, equal negative 7. No, that one didn't work. So I can mark that one out. If it had worked, I'd have circled it. But I still have another answer to check. Let x be negative 4. So every place you have an x, put a negative 4. So put a negative 4 here and a negative 4 here. So this would be do the math. Don't move anything. 5 minus negative 4 is 5 plus 4, which is 9. And then this is negative 4 minus square root of 9 is 3. And negative 4 minus 3 is negative 7. Yes. So what answer did I just try? The negative 4. So this problem, once again, has one answer. So remember, if you feel like you're working your problems right, but every time you check your answer, it's not working, it could be because you didn't check your answer. So all radical equations must be checked. So this concludes section 7.6 video, part 2. So we have one section left for this course, and that's section 8.1, and we will do that in our next video.